All right, let's look at how to solve some projectile motion problems. Let's say we have the ground here, and we're going to have an object that is projected from the ground along this direction initially, and that will be the velocity there, and an angle theta above the horizontal. Now, as this object moves through the air, it slows down when it gets to the top, but then it speeds back up as it gets past the top and onto the bottom. So as the object goes up, 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 the velocity component, remember that means the piece of the velocity that's in the y direction, decreases over time. So initially we might have a velocity in the y direction, and then that velocity in the y direction gets smaller and smaller until the velocity in the y direction is 0 at the top. And then as it begins to come back down, the velocity in the y direction is increasing and increasing and increasing until it is the same as it was when it left the ground there. Now, the velocity in the x direction, the x component of the velocity, is the same throughout. The velocity in the x direction does not change because there's no acceleration in the x direction. The whole time it's moving in the x direction, there is nothing pushing or pulling on it. It is moving with a constant velocity in the x direction. So whatever our initial velocity in the x direction is, will be our final velocity in the x direction. So that makes that easy to solve. The velocity in the y direction is equal in magnitude, that means size, but opposite in direction as the final velocity in the y direction when the object goes from the ground back to the ground. And so this negative or pointing down vector represents that it's in the opposite direction. So let's look at this. We have a soccer ball kicked with an initial speed of 5 meters per second at an angle of 30 degrees above the ground. What is the maximum height of the ball? So just like a free fall question that we've done before, if we know that the velocity in the y direction, the highest point, is 0 here, and the acceleration in the y direction and the up and down direction is the acceleration due to gravity, if we can determine the initial velocity in the y direction, we should be able to find our maximum height. So the first step is to figure out what is that initial velocity in the y direction, because I've been given the magnitude and direction of the velocity. From our notes, the initial velocity in the y direction is v sine theta. Making sure your calculator is in degree mode, 5 sine 30 should be 2.5 meters per second. So now we know the initial velocity in the y direction. We know the velocity final in the y direction is 0 at this maximum height. So the thing I don't have is time. And if I remember correctly, there's a v final y squared equals v initial y squared minus 2g delta y equation that does not have a time in it, a t in it, that's very helpful to use. Substituting in my final velocity, initial velocity, and g, I can solve for delta y. First by subtracting 2.5 squared from both sides. So then I'll have 2.5 squared, which is 6.25, negative 6.25 divided by negative 20 will be our delta y. And the height's about 0.313 meters. Now let's find the time it's in the air. Now we know the initial velocity in the y direction is 2.5 meters per second. And we know that the final velocity in the y direction at the highest point is 0. So that's, if we imagine this object is going up, up, up to the highest point, and then comes back down, then if we can find the time it takes it to get to the highest point and double it, we'll have the total time. So if v final y is equal to v initial y minus gt from free fall, because this object is just in free fall, we set our final velocity equal to 0, and we know our initial velocity in the y direction because we solved for it earlier. It's 2.5. We use 10 for g, and then 0 minus 2.5 is equal to negative 10t. So then 0.25 is equal to t. Now that is just the half time, the time to get to the highest point. So to find the total time, we need to double that. So then 2 times 0.25 is 0.5 seconds. So part C, how far in the horizontal direction does the ball move? So remember, the ball's kicked and it goes up, 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 and comes down, down, down. And so we want to know, what is this horizontal distance? How far away? So that's our delta x. Now, because this is free fall motion, the object is only accelerating in the y direction. Remember, the acceleration in the y direction is g, but the acceleration in the x direction is 0. And this is what we're going to use here. And that means that the velocity in the x direction is constant. It does not change. So if you remember our constant velocity equations, our delta x is equal to the velocity in the x direction times time. So now I need to find what is this initial velocity in the x direction. So let's solve for our velocity in the x direction. So again, from the trig earlier, the velocity in the x direction is v times the cosine of the angle. So we have 5 meters per second from the problem earlier, and then cosine of our angle, 30 degrees. So this is equal to about 4.33, and that would be meters per second. So now I have the velocity to substitute back into here, and this time will be the total time it's in the air. So now we're going to make our substitutions. We'll have our delta x, that's our horizontal distance, time is 4.33 times 0.5 seconds. We just found that a minute ago. And so we get that the change in position was about 2.16 meters. And so that is this horizontal distance away.